to this area, solution type, you have many different solutions available related to this analysis type, right? So you have linear statics, you have, this is also linear statics, but if you have many subcases, this is super element. I'm not sure what was this. I never used this one. This is for flexible body, for example. This is again for buckling, for example. So based on the type of problem you are doing, you can pick the solution type relevant to that one, right? If you want to perform a generic one, you go with the regular linear statics option in this case, which is this. The other thing I am interested is that what type of outputs I'm getting. So this is in case control. If you click case control, you come here on the output request, and this is edit. So if you click on this, key size signature sign icon, if you click on edit, it will open and it will show that these are the different, outputs that can be there. So for example, we can see, again, this is showing all different types of outputs. I can be very specific. I can say, I want to see the outputs related to this solution. So now it is showing me only the outputs related to this one, right? So displacement, it is checked, so it will be encountered. I can look into the elastic strain. I can say I want to monitor this one as well. If I want to talk about forces, for example, I can click force as well. So I can say I want to, so whatever you check, it will available at the end of the solution to you. You can monitor this one as well, right? Similarly, if I click stress, for example, stress is already checked, yes. Strain, I can click on strains as well. I'll click on these ones as well. Force I already did. So whatever you want to select, you just check that one. It will be available to you at the end of the solution. Press OK, and then you will press OK. So now you did the initial setting of the whole thing. Okay. Now the CAD model is there. Now students, there are two environments you need to keep in mind here. So if you see here, simulation file view, you see two folders. You see this one. This is with the signature simulation, and this is with the signature FEM, right? So if I double click simulation, you can see that this will change here, right? This ribbon bar has different options. It's more like when you are completing, when you're moving towards completion, you need these type of commands that time, right? When you are fixing the beam, when you are applying load, but it doesn't have that how many elements should be there, like you are subdividing the whole geometry into small elements, right? And then you are solving each element separately and then combining the solution together. That's how the finite element solution works. Okay, so here what you did, I do not need to work on this one. First, I need to work on this FEM module, right? And again, you will see that the ribbon bar will change as a result of this thing. I need to click on the physical properties first. Here, I would say that what type of elements I need to work with, right? Now, if my object is 3D solid, right? I can work with this thing, P solid. The element type will be solid 1. If I am going to work with the beam element, for example, then beam properties should be there. So these are beam elements, right? These two can be used alternatively. I pick this one, then I say create. So I will create this one. Yes. If you are analyzing beams, then your element should support the beam, right? Because beam should facilitate the stresses and the bending, right? But it should not have any torsional capability. So when you specify this thing, you are saying that it is the element you are using, it supports only beam, right? If it's a solid one, that can be of anything, you can pick P solid. Then it has all different types of things. Beam, you know that you don't study the twisting. It has only the flexural loads and the axial loads mainly, right? So this will be supported here when you click the name, the type of the element, right? So I pick the element type, then I select create. Now students, here this is a very interesting part here, because if I click on this small icon that shows that says show section manager, and if I click create, so by default it tells me it has many cross sections in it. So I can assign any cross section to the line that I have created, right? If I click here, all these different type of cross sections are there, beam cross sections, right? All these options are there because I selected beam initially. So I can say that as per the problem, I am working with this I type beam, and I have just, like these, what you can say, these input buttons where I can just put the values, right? And I can create the beam. So if I can currently say how it looks like, if I click preview, this is how the cross section look like right now. Cross section of the beam, cross section of the line, yes. So I'm assigning a cross section, beam cross section to the line, right? I can say that no, this is not required. I need to change this dimension to 50. And then let's say, so I need to work with, let's say in this problem, this cross section. Yes. It is given in the problem. So the problem that you're solving for a beam, it tells you that what beam cross section you are working with. So the dimensions are given in the problem. No, I didn't make the cross section. It come automatically. Yes. When you select, this is the advantage. This is what I'm saying. You don't need to make a 3D picture and then use it as a beam. You can just make one line and you assign any cross section to it, right? And you can vary the thing. One very important thing, students, that you will see here, if you click evaluate section properties. So if you click here, the file that appears to you, this has all the data of that cross section. Shows the dimensions, what's the cross-sectional area, the centroid with respect to Z, Y, the shear center, like all this information, moment of inertia that you usually do with hand calculations. You remember you do it by hand, right? When you're solving beams, right? You calculate moment of inertia and all these things separately by hand calculations. There, with respect to the cross-section, everything comes automatically, okay? When you click on this one. Then after this, you say, okay, after assigning the whole thing. So I assigned this cross section. Okay, I will close this one. One thing, students, that you need to see here, material is not assigned yet. So I can click on this choose material, and I need to tell what would be the material of this beam, right? So if I go, I have a big library. I can say this is a steel material beam. If I press OK, now steel is here. Okay. And I can press OK. This is a constant profile cross section, but it can be tapered if you want. Press OK to this one. And I would say after this one, say close, let's say. Then after this one, student, now I need to assign mesh to this one. Mesh means that I am making it into small elements. How finite element works? The big geometry is basically divided into small geometry portions, right? So either a small length, in this case, its big length will be divided into small lengths. For each length, you get the solution, and then you superimpose the solution of everything to get the final result. That's how finite element works, basically, right? But again, it's a dense course. I'm not sure you're aware or not, but we have a course, Dr. Weil offers this course, which is called finite elements, right? Which is only talking about what is the mathematics behind this process. So if we go forward, students, here I have different types of putting the mesh. I need to, because I have one line, it's not a 3D object, I can click on 1D mesh, one-dimensional mesh. The object that I need to use here is this line. Okay. It would be, by default, it would be realized that this is the beam element, because I have assigned already beam. How many divisions you want on this line? So it's up to you. Number of elements, that how many small elements will be defined, or how many divisions will be there on this line. I can say that go ahead with 25, right? Here I need to link what I have done in the previous step here. So I will click on new collector, right? And if you see here, I need to say this one, and I need to pick the one that I produced. This is the one that I produced previously. I will press OK. Everything is there. I will say OK now. Okay. So I did this thing. Now, one thing, students, that can be of your interest, I can look into different configurations. If you click here, I can look into in this isometric orientation, right? You want to look this thing in top view. This is the top view, right? So you can select the view you want, and with the mouse wheel you can go for zoom in and zoom out option. If I click here, 1D mesh beam, this one, right? If you click open this, the 1D mesh that we have assigned as a collector. If I right click on this one, and if I click on the edit display, here the display is off right now. But if I say show me the solid display, and if I say okay or apply, you can see that now you see the cross section I have assigned, right? So this is the cross section assigned. If you keep the solid on, it will show you the I-beam. So your I line looks like a beam, whatever you have assigned, right? Sometimes in order to facilitate picking, because we need to pick nodes when we fix the nodes and when we apply nodes, sometimes it gives you trouble when you are picking. So recommendation is that you keep it off. But before this thing, there is one problem here right now. If you see the system X and Z system I have assigned, right? Generally Z is the vertical one. So your beam is 90-degree tilted right now, right? It needs to flip up so it can go in the Z direction. So what you can do, if you want to keep it like that, then you keep in your mind that your beam is oriented like this, right? Which means when you apply a load, it will be applied in the Y direction, right? Because this is how the beam will come, right? Otherwise, if you want to make it with respect to the right configuration, you again right click, you click edit mesh associated data, and this is the elemental axis. So you can say that it should be flipped to Y and Z. So when it is flipped to Z, you can see the orientation changes, right? You can press OK to this one, and now it's coming with a different right orientation, you can see, right? And again, as I told you, that it shows me the solid, but I can skip this part. I can again make this one a none, for example, and again switch the display to the line. But you know that how the cross section is assigned, right? So students, that's what we did. Now I have assigned the material, I have defined the element, I have defined the elements, right? All these three basic things are done. These basic things will only be available only in this second mode, on this FEM mode. Now I need to go and fix the beam. That this is the point where it is fixed. This is the load I'm going to apply, right? So I will go double click the simulation environment. Okay. So you double click the simulation environment. Now these values are different now, right? So technically, in order to complete the beam, you need to click that what should be the constraint type, like is it fixed, or is there a pin joint, for example, or is there a knife edge support, what type of support is there? All these different supports are there, but for the time being, we'll go with this fixed constraint. I want to fix one node, one end. So fixed constraint to facilitate the, like if you see, I can pick the node, but to facilitate the selection, I can change this thing. This is already node, by the way. So I want to fix it from here. I clicked on the node, right? Make sure that your filter is node, so you can easily pick node, right? Otherwise, there are many things. When you come near, there are many, it can pick line as well, right? So in order to have the right selection, you make sure that you pick the node. So I fixed the node, and now I am going to apply force here in Z direction, right? Negative Z direction. So I click on the load type, force. This is the node. I say that I want 1000 Newton force. In which direction, students? In Z direction, right? So from here, I will pick, these are directions. So it should be this one, negative Z. It's showing you the direction. You click, and if you see, it is showing you that Z is here, so negative Z. So it is only showing you direction, by the way, right? It doesn't mean that the load is applied there. Load will come here, but this is only on the origin showing you the direction. Okay. Where is the window? This is the window. Then you press OK. So this load is applied, right? And this is a simple problem. We do not have many other loads. So if you have more loads, then you can assign the load values or other moment values whatsoever on the other sides as well. So you did this thing, and then students, after this, you click on the solve option, right? First click, let's say solution. Okay. And then click solve. Press OK. Why is that so? It was fixed. One node is fixed, yes. Okay. So this solution was, there were two solution files, one from the previous one. So I need to delete one of them. For you, it won't appear because I redid this thing before coming here. So it was showing me this thing. That's why it gives the error initially. But for you, when you click, it will solve like this, the one you see now. So students, once you solve, you can close this thing, and this second one here, this is post-processing, right? All these steps, what you have done are here in this part. When you click here and you click on this result structural solution one, you click load. So these results, solved results are loaded here now, right? So for example, if I talk about nodal displacement, so you have three displacements coming, right? If I press Z, do you see any displacement? No, right? Because Z, it's not, if the force is applied only in Z, so deflection is also only in Z, right? You don't have Y and X and Y deflection. If load is in Z, it will only be showing you the values in Z. So here you can see the magnitude, right? If I show you, for example, the from here, this is the front view. Now this is the, so this is how it is, okay? And if you want, so there are many options here that you can do, right? We'll learn as we proceed with them. But for example, if you need to show the animation, you can show the animation of the result with the undeformed and the deformed simulation, right? You can remove this one. One other important thing which is good here, okay, this is Newton. Anyway, I'll show you on the displacement part. You have one tool here which is called beam cross-section view tool. So if you click on this one, and let's suppose these, you know, these are elements, right? Right, this is the element, you divided the whole bar. So for example, if you want to see what is the situation here, you click, and if you press apply, it shows you the cross section, right? That how the cross section is having variation, right? So for the time being, students, what you need to do, you need to replicate the tutorial, right? Save it, and then you need to pick 5 different cross sections, right? And then you kind of compare their deflection. So I would say maybe what you can do, you can make a table, right? So in one table you have cross section 1, 2, 3, whatever name is there, 5 cross sections. And then along the length of the beam, like this is, I'm showing you somewhere in the mid span of the beam, right? So position wise, you can put the pictures of all these cross sections, maybe one cross section in the mid span and one cross section at the end, right? So this, like 2 pictures, one here and if I cancel out this one, for example, right? One from here and the other one from somewhere here. Okay, so pick one element from the midspan, somewhere close to the midspan, and same should be followed for all cross sections, right? And so you make a table and you fill these two cross sections, one in the midspan, one at the end, right? And then you finalize it and you submit that document to me, right? So this is something what is required initially, yes. File for this one, like whatever you are saving in a folder, in the end you zip that folder and submit that folder, right? All 5 should be in the one same folder, the way I changed it, if you remember initially. And on one document you make like a table, so one cross section, second cross section, third, all 5 here, one picture of the cross section in the midspan, and one at the end for all cross sections, right? So you will go ahead and you will do this thing. Cross section, for example, I-beam has its own values, right? When you pick something circular, automatically it will change. You can say that outer dia, inner dia, for example, right? So automatically things are not the same. It will change when you change the cross section. So students, that's basically the second lab. Okay. Let me go ahead now and online students, did you get what I said?
Yes, doctor.
Okay.